In mini unit chapter 2, lesson 2, we're actually going to be working with lesson 2-10 from our book. We're going to express numbers in scientific notation. We use scientific notation to show really, really big numbers or really, really small numbers. So, for example, scientific notation always has one digit to the left of the decimal, kind of like 3.42. So there's always one digit to the left, and then to show that it's a really big number, we multiply by times 10, and so obviously if we multiply by times 10, we're going to move the decimal one spot. But if I multiply by times, let's say times 10 to the fifth power, well, 10 to the fifth power is really 10 times 10 times 10 times 10 times 10, or actually like 100,000. So if I were to write that out in standard form, I would write 3.42, and I would actually move my decimal 5 places to the right. So it'd go 1, 2, 3, 4, 5. All right, so my new number then would have all these zeros after it, and so it would equal 342,000. All right, so 3.42 times 10 to the fifth equals 342,000 because we moved it 5 places, 1, 2, 3, 4, 5 to the right. Okay, now we can also show really small numbers the same way. 1.68 times 10 to the negative fourth. Now, we know that any exponent with a negative exponent, we can rewrite that as 1 over 10 to the fourth, okay? So what that means is we're actually going to be dividing by 10,000, because if we move it, 4 places to the right, we would have 10,000. There's the zero that's there already, then you move it 4 places over, okay? Um, so in order to write this, we're going to need to write 1.68, and then what I'm going to do is I'm going to move it 4 places, not to the right, but to the left. 1, 2, 3, 4. Because you got to think, it's like division, okay? And whenever you're dividing by 10, you always move the decimal to the left. So what we'll do there is any of the open bubbles, we will put zeros in. And now we can rewrite the answer as 0.000168. Okay, so 1.68 times 10 to the negative fourth is the same thing. It's equivalent to 0.000168. They're the exact same thing. All right, so let's try this out a little bit. Okay, so by multiplying by a positive power of 10 moves the decimal point to the right. Multiplying by a negative power of 10 moves the decimal point to the left. All right, so here we're going to say 9.62 times 10 to the fifth. Well, one thing that I always say here is if it's a positive exponent, we know that the answer will be greater than 1. Okay, it's going to be a pretty big number, but definitely greater than 1 if it's a positive exponent. Okay, if it's a negative exponent, the answer will be less than 1. Okay, it's actually going to be between 0 and 1. It's going to be a really small number. Now, if it's negative, obviously it'd be between 0 and negative 1, but that's another story. So here we go, 9.62. All right, so times 10 to the fifth means that we are going to move it 5 places to the right. So 1, 2, 3, 4, 5. All right, so we'll fill those in with zeros. So 1, 2, 3 zeros. And I'll rewrite my answer is 962, 1, 2, 3 zeros. And so 962,000 is equivalent to 9.62 times 10 to the fifth. Notice what they did there is they put the decimal to right here. Okay, when you write it in scientific notation, you can only have one number, right, like the 9, one number to the left of the decimal point. So just like in my 2 examples, I had a 1 to the left of the decimal and I had a 3 to the left of the decimal. You can't write scientific notation with more than one number to the left of the decimal point. All right, let's try another one. So we have 5.32, and we're going to move it 4 places to the right because it's positive, so it goes right. And positive means we're going to have a number greater than 1. Okay, so we'll fill these circles in here, these bubbles. So we'll have 53200. So 53,200 is our answer. Okay, and that answer is definitely greater than 1, so we're on the right track. See, if I would have done it the other way, now this is the wrong way, but for example here, 5.32, if I would have moved it 1, 2, 3, 4 to the left, take a look, I would get 0.000532, and that is less than 1. Okay, and since it's less than 1, then that would mean that this would have to be a negative exponent. But it's not. It's a positive exponent, so we need it to be greater than 1. All right? So this, again, this is incorrect. This is not how to do this problem. This would be 5.32 times 10 to the negative 4th right there. Okay? Okay, so now we get one of those examples. So we have 2.85 times 10 to the negative 6. Now, since it's negative 6, we know we're moving left. So we go 1, 2, 3, 4, 5, and 6. So let's fill in those bubbles with zeros. 1, 2, 3, 4, 5. So the 6 doesn't represent how many zeros. Notice I moved the decimal point 6 times, but I only wrote 5 zeros because the first time was to get outside of this first number. Okay? All right, so our answer then is 0.123450285. All right, so these two are equivalent. 2.85 times 10 to the negative 6th is equivalent to this number right here. Now, for showing work for today's homework, I would like you to draw these bubbles in. I do need to see that. You could start by copying this out of the book. Copy that out of the book, and then you probably need to rewrite it and give yourself plenty of room to move the decimal around. Okay, so we have 3.81 times 10 to the negative 4th. So that means we're moving left. Okay, 1, 2, 3, 4, and let's fill those in. We have 1, 2, 3 zeros, so 0.000381, and that is our final answer. Again, for your homework, you probably go ahead and copy this down, then rewrite this, give yourself some room, and then show me your final answer without all these lines in there, okay? Clean it up a little bit for your answer. Okay, so now we're going to go from standard form to scientific notation. Now, if you have it kind of down, and right now you're thinking, oh, this is kind of easy, this is the part that starts to get a little tricky. This kind of tricks people up a little bit. So there's some directions here. It says move the decimal point to the right of the first non-zero digit, count the number of places you move the decimal point, and find the power of 10. All right, so I kind of have some steps here for you that have helped students in the past. All right, so again, like I've already said, the decimal point has to go right here because there can only be one number to the left of the decimal. So we're going to say negative 9.315. Now, I'm not worried that this is a negative. That's just fine. So we know that this number is greater than negative 1. Or excuse me, it's actually less than negative 1, isn't it? Okay. So again, if it's outside of 1 or negative 1, and it's not between negative 1 and 1, we know then that we're going to have a positive exponent, okay? Because this is the absolute value of this number is pretty big, okay? And that's kind of what I'm thinking about here. So next I'm going to say times 10, okay? And we're going to say to the positive because, yes, you're moving the decimal to the left, but it's kind of like opposite a little bit, because look at our number now. Now you would have to move the decimal to the right, and to the right we need positive, okay? So it's a little tricky when you're thinking about it like this, and you just got to remember that if the number is between -1 and 1, all right, you're going to have a negative exponent. All right, if it's less than -1, if x is less than -1, meaning like this number here is less than -1, or if x is greater than 1, then we're going to have a positive exponent. Okay, so these are kind of your rules that I want you to kind of think of. And always, always, always determine whether your exponent is going to be positive or negative before you even rewrite it in scientific notation. So here, the number is pretty big, you know, relatively speaking, absolute value-wise. So we know that the exponent is positive, so don't let it mess you up. Now, let's count. 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th, okay? Now, if we try it, we'll go -9.315. Let's move it 8 times to the right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's a 0, 1, 2, 3, 4, 5 zeros. So look at this one, 1, 2, 3, 4, 5 zeros. So that does work out. So you can always, you know, try to build your number again from the beginning and see if it actually works. All right, so let's try this one again. Is the exponent going to be positive or negative? Well, this number is bigger than 1, so it's going to be positive. So I'm going to write 3.56 times 10 to the, now we got to count. So it's right here. So we're going to go 1, 2, 3, 4, 5, 6, 7 times 10 to the 7. All right, we knew that the exponent would be positive because this number is bigger than 1. Okay, now this number is between 0 and 1, so right away the exponent we know is negative. Okay, so we're going to go 4.43. Notice I always put the decimal right in there, so I only have one number to the left of the decimal point. And then I'm going to say times 10 to the negative. We already know it's negative, so just get that figured out right away. And then we're going to move it 1, 2, 3 times. And we knew it was -3 because this number is less than 1. Less than 1, between -1 and 1. Okay? All right, so again, this is between -1 and 1, so the exponent is going to be positive. So I'm going to write 6. Excuse me, that is wrong. The exponent must be negative because this is between -1 and 1. So we have 6.53 times 10 to the negative, and now let's move it 1, 2, 3, 4 times. Okay? Now again, you can always check it by going the other way. So remove it 1, 2, 3, 4. You'd have 3 zeros, so that's 1, 2, 3 zeros. Okay? All right, so we're going to do a little comparing here. The question asks, says the table lists the average radius at the equator for each of the planets in our solar system. Order the planets according to the radius from largest to smallest. So we want the largest first. It says largest to smallest, okay? So whenever I'm looking for the largest number, I'm always going to look at the exponent. So 3, that's pretty big. 4 is big. So all the 4s are going to be bigger than 3s. And then I take a look here. So I'm going to compare the 4, this one, and this one, okay? It doesn't matter what the other number is. If I'm multiplying by a factor of 4, exponent of 4, it's going to be bigger than any exponent of 3, all right? Now, this is a 7. This is a 2, 6, and a 2. So the 7.14 is the biggest. So I'm going to say, it says order the planets. So I'm going to write Jupiter first. All right, I'll kind of put a check mark so I know that one's done. And then I'll look over here. So this is a 2, a 6, and a 2. So I'm going to put Saturn second. And I'll check that one off. And this is a 2, 4. This is a 2, 5. So Uranus is next. And then finally Neptune. All right, so we'll get our gas giants out of the way first. And now I'm going to continue my list, but I'm going to go to the next section here. Now I'm dealing with all the threes, all right? So I have a 6 here, I have a 2, a 3, and a 6. This is 6-3, this is 6-0, so Earth is the next one on the list. So we'll check Earth off. So let's go to the other 6. Again, this is a 3, 2, and a 6, so Venus is next. All right, and I have 2 left. I have a 2 and a 3. Obviously, Mars is going to be next with the 3. And Mercury. All right, so we got those done. So as you take a look here, that was actually pretty easy to compare. I didn't actually need to work it all out. You just look at the exponent first. All the ones with 4s are going to be 10 times, at least 10 times greater than any of the ones with 3s. All right, so those were all going to be the first options for us. All right, that's our last example for today's lesson. Scientific notation is great for writing really big or really small numbers.